Welcome to mathematics lesson. In today's lessons, we look at coordinate geometry. Specifically, we look at gradient. My name is Mandila Masie. In today's lesson, I'm expecting you to define the gradient and define the gradient. So look at the coordinate geometry. Specifically, under coordinate geometry, look at the subtopic of a straight line. So before we go into calculations, we have to know the meaning of the word gradient. What is gradient? What is gradient? Yes, Joseph?
The steepness of the line.
Okay? Gradient is the steepness of the line. Gradient is the steepness of the line, or the slope of the line. So that is the definition of gradient. Gradient is the steepness of the line or the slope of the line. So once you have defined the next, we can look at these lines. There are many lines. So for us to calculate the gradient, the line should be sloping. If the line is not sloping, we'll look at such lines. What are the values of their gradients? So before we proceed, we have to take note of the following lines. One, look at the horizontal line. So horizontal line has the gradient equal to 0. Then the other one, we look at vertical line. The vertical line has the gradient and defined. So these two lines, the horizontal line has the gradient equal to 0, the vertical line has the gradient and defined. Meaning that if we are given a horizontal line, we know that the gradient is equal to 0. So we'll come and improve this as we do the calculations. Since we have already defined, then from there now we can look at the formula for us to calculate the gradient of a straight line. So for gradient of a straight line, the formula is formula for gradient of a straight line. So gradient is equal to y2 minus y1 over x2 minus x1. So the M will stand for gradient. So gradient is being calculated by, you should have the value of y2 minus y1 over x2 minus x1. So once we have these values, it means we can proceed to calculations of gradient. Let's look at the example. Find the gradient of a straight line through the following A 4,6 and B 5,8. So find the gradient of a straight line through the following points. So the points given, we have A, which is 4,6 and B 5,8. So we are given the points, then from there, now we have to identify. According to our formula, we should have the y2, y1, then x2 and x1. So we will therefore, according to the points that we have. So I'll write the points, and we have 4,6, and B, we have 5,8. Then now we label these points. So when you are given the coordinates, the first number that becomes a value of x. So meaning that this one will be x1, then this one will be y1, then this will be x2, then this one will be y2. So when you are finding the gradient, regardless of the order, the way you name the points, the answer has to come out the same. So what I mean is, if we want this one to be x2, then this one y2, then this will be x1, y1. Then you will proceed with the formula, the answer will be the same. So you are at liberty, you can name the numbers in the order you want. From there now, we can read the formula. So I say our formula is M, which is standing for gradient, is equal to y2 minus y1 over x2 minus x1. Then next, we'll do the substitution. We have already named the coordinates there. So we just start now the substitution. So y2, what number are we going to put on y2? James? 8. So y2 is 8. So put 8. Okay? We move on. The next one is y1. So we have the label diagram. So the y1 is equal to 6. Then we come to x2. X2 there, the value is 5. Minus. Then we come to x1, the value is 4. Then we proceed now with the subtraction there. We have 80 minus 6. Fred, 2. So 8 minus 6 is 2. We come down, 5 minus 4. Yes, sir? 1. 1. Then you have 2 divided by 1. 2 divided by 1. 2 divided by 1. Joseph, 2. So it will be 2. So meaning that a straight line which has these points, its gradient will be this. We proceed to another example. Yes. And the gradient of a straight line through the points. First one, which is -4, -6, and D, -2, 0. So the question is find the gradient of a straight line through the points C, -4, -6, D, -2, 0. Finally, the gradient. Anyone to try? Try and solve this one? Yes, Henry, you can try and try.
A is equal to 2y minus y1 over x2 minus x1. y2 is 0 minus y1 -6 over x2 x1 negative times -6 positive 6 negative times -4 6 over positive 2. Gradient is 3.
Is it okay?
Yes.
So, first we write the formula. We are saying F is equal to y2 minus y1 over x2 minus 1. Then next we have to the points. So the way he has done it, meaning that this one was our x1, this one was our y1, then this was x2, then y2. Then next, he did the substitution, where there is y2, it is 0, minus, this minus is the one which is in there. Then the y1, it is -6. So we have to bring the -6, we will not ignore the negative there. Then on the x2, it is -2, so write exactly what it is, -2 minus, then the x1, which is -4. So when these signs are following each other, it means there is multiplication. So negative times negative, it is positive. So we are saying 0 plus 6. So 0 plus 6, we have positive 6. Then again, there are those signs which are following. So negative, it needs to come to positive. So it will be -2 plus 4. So -2 plus 4, these they have different signs. So it means we are subtracting. So it will come 6 over 2. So where the 2 is coming from is -2 plus 4. So the directions are different. We start from the negative, then we move to the positive. So we end at +2. Then from there, we have 6 over 2. The 2 can go into 6. So in this case, the common number which can go into 2 and 6 is 2. So say 2 into 2, that is 1. Then 2 into 6, that is 3. So our 3 over 1. So 3 over 1 is the same as 3 because the 1 goes into 3 times. So this is our gradient. Are we clear?
Yes.
So let's look at another question. Instead of just having the points which are given directly, we can also give a diagram. So in the diagram below, AB and CD are straight lines. So we have these lines, A, B, then we have C, D. Then we are given the coordinates for C and D of negative 3,0, then 2,6. For A and B of 2,6 and E 8,0. Then the question says, find the gradient of line AB. So when we are given in a diagram form, the process is just the same, the way we calculated those two examples. So we go straight. The first one was saying, let's find the gradient of line AB. So please we go to the formula. Right, what is the formula for finding the gradient?
y2 minus y1
y2 minus y1
over x2 minus x1.
x2 minus x1 to the diagram. We are dealing with the line AB. So this is our line AB. Then now calculate the points. So the points that we have are 2,6. Then the second pair of coordinates is 80. Then from there we label them. The x1, the y1. Okay, we begin with this one. Let's have this one. The labeling
X1.
So this one will be x1. Then the 6 become the y1. So you always begin with the x. So since this is x1, y1 will be x2, y2. Then from there we will substitute in the formula. So we move on. So our m equal to y2, then we go straight to where is y2. So y2, that is 0, minus, then we come to y1, that is 6 over, then we go to x2, which is 8, minus, then x1, which is 2. So m is equal to, we move on now, 0 minus 6. Look at negative 6. So 0 minus 6 it is negative 6 over. Then move on. 8 minus 2. Yes, sir. 6. So it will be 6. So we have negative 6 over 6. Meaning that we can divide that.
Yes.
So negative 6 minus 6. What do we get? Negative 6 minus 6. Negative 6 minus 6. Yes, John. Negative 1. So that will be our gradient. So line AB, our gradient is negative 1. Then we move on to line CD. So the next one we're moving on. Find the gradient of line CD. So this is the line CD. Anyone can come and find the gradient for this line? CD. CD. Yes, Joseph.
First, we need to write the formula for the gradient. The gradient M equal to y2 minus y1 of x1 x2 minus x1. After writing the formula, we need to write the coordinate CD. C -3, 0. D 2, 6. After writing the coordinate CD, the issue is what we present. Y2 first, we need to indicate y1, the x1, y1, which is y2, y2. So y2 is 6. 6 minus y1, which is 0, or y2, which is 2, minus x1, which is -3. 6 minus 0, it is what? 6. Or 2 minus -3, which is positive times negative times negative, which is positive. 2 plus 3. 6, which is 2 plus 3, which is 5. This 5 can go into 6, which is 1, remainder over 5. This is the gradient.
Is it correct?
Yes.
The way he has explained that. First, we write the formula. Gradient is equal to y2 minus y1 over x2 minus x1. Then next we have to indicate. So -3 is our x1, then 0 our y1, 2 our x2, then 6 our y2. Then next we press. So where there is y2, we put 6. Where there is y1, we put 0. Then where there is x2, we put 2. Where there is x1, we put -3. Then from here on, we do the operation. So 6 minus 0, that is 6. Then 2 minus -3. So these signs are multiplied to give us the plus sign there. So 2 plus 3, we have 5. So 5 into 6, we have 1, remainder 1 over 5. So that is it, the gradient of the line CD. Are we together?
Yes.
Okay. Now we have come to the end of today's lessons. My name is Mandira Masie on behalf of the production group. Bye.